Now let's talk about computed signals. Now they are actually the signals that are dependent on other or previous signals. In other words, the computed signal derives its value from other signals. Let's implement a few simple examples to understand how the computed signals work. First, I am creating a simple writable signal named count with value 0. Then creating another signal remaining count which will be computed signal, so I'll assign a computed function. A computed signal is created by using the computed function. This function takes a callback function. Unlike the writable signals, the computed signals are not writable, meaning you cannot directly assign values to a computed signal like we used to do with writable signals, that is by giving set method. This will show a compilation error as the signal is a computed one. Let me give an arrow function inside the computed function and will return a simple calculation 100 minus this dot count. Now let's display the value of remaining count inside the template, giving h2 signal colon and the count and parentheses, that is the signal. The next h2 with computed signal, giving remaining count and parentheses. Now let's check the output. So the signal value is 0 and the computed value is 100. Now let me change the signal value to 20. Let's check the output. And now the computed value is changed to 80 because the signal value which the computed signal is dependent on is changed. So by this we can state that the computed signals are dynamic signals. And to check that again, let's see one more example where we display the sum of array values. I'll create a signal array and passing 4 values. Creating a computed signal sum ARR, that is sum array, and giving the computed function that returns the sum of array. Now I'll use the reduce method to get the sum of array values, passing the accumulator and current values as sum and I and returning the sum of them. And the method that mutates the array, so we'll give modify array. That's it. Let's update the template as well. I'll give a division, class subdivision 2, giving UL and inside giving an li with for, let value of ARR, the template value, then adding a value button, binding the modify array method with the click event and will display the sum in the h2. Let's check the output. We have the summation getting displayed. Now when I push the value in the array, you can see the computed signal is getting updated. So the value of the computed signal depends on the value of the array signal. So when the new value gets pushed in the array, the computed signal gets updated. This is what a computed signal is. They cannot be mutated like the writable signals, that is by applying methods like update or set. So with the help of computed signals, you follow an even more reactive approach for building applications.